Okay, this is the solutions for homework 7-4. We're going to figure out the vertex, y-intercept, and behavior, and the roots for each function. Just real quickly, a quick note, we can figure out the vertex and the end behavior just using this. Y equals a times x minus h squared plus k. So if we look at problem 1, for example, the function is y equals -2 times x plus 1 squared plus 8. Now in this case, a is -2, x is h is -1, and k is 8. So let's write that down. A is -2, h is -1, and k is 8. Sometimes people have trouble with h because when you look here, you see a +1. But remember, the formula has -h in it. So one way people think about this is they just basically switch it around when they're writing h. So what can we do with this information? We know that the vertex is going to be hk. So in our case, the vertex is -1, 8. Oops. The value for a will tell us the end behavior. So in this case, a is negative number, which means that we know the end behavior is such that the function points down, the parabola points down. So that's like the two parts that we can do really just from reading the formula. Now we have two other parts, which is we can calculate the roots. And the way you calculate the roots is you make y equal to 0. So I'm going to reread problem 1, but instead of saying y, I'm going to say 0. So this becomes 0 equals -2 times x plus 1 squared plus 8. We're going to solve this equation, we're going to subtract 8, divide by -2, -8 divided by -2 is +4, and equals x plus 1 squared. Okay, now we'll use the square root method to isolate the variable x. One of the keys in the square root method is you have to consider both the positive and the negative root. So the square root of 4 is 2, but I need to consider the +2 and -2. And so in class, this is where we wrote our two equations. 2 equals x plus 1, and -2 equals x plus 1. We solve each of those equations. 1 equals x. -3 equals x. So the roots are 1 and -3 for problem 1. Our final portion that we need to consider is the y-intercept. That has to be calculated as well, although it's not as difficult to do that as solving for the roots. So for the y-intercept, x is 0. So I'm going to reread problem 1, but I'm going to say 0 in place of x. So the equation is y equals -2 times 0 plus 1 squared plus 8. And now I simplify. 0 plus 1 is 1. 1 squared is 1. -2 times 1 is -2. -2 plus 8 is +6. And that is the y-intercept. So let's take a step back and write down all of this information from problem 1. The vertex is -1, 8. The end behavior is down. the roots are 1 and -3. And the y-intercept is 6. If I were to graph this, it would look like so. I'll use a different color for that. Use black. So the y-intercept is 6. The roots are 1 and -3. The vertex is -1, 8. So if I were to graph this, it would look something like that. Maybe I can put this as -3, 0, and 1, 0. And this should match what you get on GeoGebra. So let me put this on the screen here. And I'm going to type this equation in. I think I can get this all in one shot. Y equals -2 times parentheses x, what is that? Plus 1, close parentheses squared, plus 8. And we can kind of see it here. It sort of matches this figure there. I'm going to put on the special points. We also used in class the tools to select the objects. I think this is gonna, no, doesn't quite do it. There we go. I'm gonna put settings, and I wanna see the values so we can look at these. So we have 1, 8, 0, 6, 1, 0, and -3, 0. Those are the same points here from our work. And so that matches. I'm going to have the solutions posted for problems 2 and 3, but you would basically follow these steps.